सबको हमारी ओर से इस महत्वपूर्ण शाम में स्वागत, नमन, वंदन, अभिनंदन। आज की शाम बहुत ही महत्वपूर्ण है और इस महत्वपूर्ण शाम में हम एक नई आयोजन की ओर बढ़ रहे हैं। तो पहले एक छोटी सी झलक उस आयोजन की और बाद में हम आगे बढ़ते हैं। टीचर साइंटिस्ट इंडिया NCRTS इंडिया, नेशनल काउंसिल ऑफ स्टूडेंट साइंटिस्ट इंडिया NCSS इंडिया, साइंस राइटर्स एसोसिएशन ऑफ त्रिपुरा इंडिया और वॉलंटरी नॉन प्रॉफिट एकेडमिक साइंस ऑर्गेनाइजेशन दासा इंडिया की, जो कि मान्यता प्राप्त है त्रिपुरा गवर्नमेंट की ओर से, उसी का निवेदन है इंडिया इंटरनेशनल सरावा स्टूडेंट साइंटिस्ट अवार्ड प्रोग्राम के तहत ISRO फाउंडेशन डे और सरावाई 75 साइंस डिस्कशन एंड लेक्चर विद स्टूडेंट्स एंड टीचर्स on topic applications of spatial techniques in geoscience, which will be done by Dr. Aniruddha, Uniyal, Head Art Resource Division, Remote Sensing Application Center, Lucknow, जो कि डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी गवर्नमेंट ऑफ उत्तर प्रदेश के अंतर्गत है। तो आगे बढ़ते हैं। आज की शाम बहुत ही महत्वपूर्ण है। आज हम अमृत महोत्सव मना रहे हैं देश भर में, सारी दुनिया में, न केवल भारत में, सारी दुनिया में हम अमृत महोत्सव मना रहे हैं। इंडियन इंडिपेंडेंस की 75 इयर्स सेलिब्रेशन, 76 इंडियन इंडिपेंडेंस डे पर, और साथ ही हम एक अमृत पर्व पर जोड़ रहे हैं हम सबको, जब हम आगे चल के 25 साल बाद मनाने जा रहे 2047 में इंडिया सेंटिनरी इंडिपेंडेंस डे। और ये पूरे अमृतकाल हम मना रहे हैं एक ओथ के साथ, एक शपथ के साथ कि देश के लिए हम कुछ कर गुजरेंगे और देश को कहीं भी ऊंचाई पे ले जाएंगे। इसी सोच को आगे रखते हुए आज हम यहाँ पे भी वर्चुअली एक फ्लैग होइस्टिंग आप सबके साथ शेयर करना चाहते हैं और सबके साथ बांटना चाहते हैं। मैं अंजन बनिक, बीइंग ए नेशनल चेयरमैन of National Council of Researcher Teacher Scientist India, National Council of Student Scientist India, साइंस राइटर एसोसिएशन ऑफ त्रिपुरा और दासा इंडिया की तरफ से आप सबको इस पर्व पर हार्दिक अभिनंदन और बधाई देना चाहूँगा। भारतवासी के रूप में हम सब गौरवान्वित है कि हम इस मुहिम में शामिल हो पा रहे हैं। हर घर तिरंगा की भी आज महत्वपूर्ण कड़ी है इस वक्त जब हम सब ये पर्व मना रहे हैं। तो इसी की सोच के साथ आज सुबह की वक्त याद करते हुए एक छोटी सी गीत के साथ हम उस लम्हे को एक बार फिर से दोहराना चाहेंगे जब हमने तिरंगा फहराया था। तो सबके साथ इस वक्त हम उसी पर्व को थोड़ा सा मना के फिर हम चलेंगे हमारी सारा भाई 75 लेक्चर की तरफ। इस अमृत महोत्सव पर हम सभी ने इस मंच से तिरंगे झंडे को सलामी दी। ये भी एक बड़ी अनोखी चीज़ है और इसकी साथ हम आगे बढ़ते हैं और आज की शाम की महत्वपूर्ण कड़ी में जुड़ते हैं हमारी जो अतिथि है उनके साथ।
ये सही है सर, ये ग्रीन कलर बाहर होता है और केसरिया इधर होता है, इसी में राइट में। आप सुन पा रहे हैं मुझे सर?
यस सर, यस।
आपका आवाज नहीं आ रहा है लेकिन आपका वॉइस नहीं आ रहा है। आप कुछ बोलेंगे जो वॉइस आया आपका? सुन सकते हैं सर? But your voice is not coming.
ओम श्री गुरुभ्यो नमः। हरि ओम। सहना भवतु सहनो भुनक्तु सह वीर्यं कर्वावहै
Can you listen to me?
तेजस्विनावधीतमस्तु मा विद्विषावहै। ओम शांति शांति शांति। हरि ओम। संनो मित्र संवरुणः संनो भगवत्वर्यमा संनो इंद्रो बृहस्पतिः संनो विष्णु रुद्रमः नमो ब्रह्मदेव नमस्ते वायु त्वमेव प्रत्यक्षं ब्रह्मासि त्वमेव प्रत्यक्षं ब्रह्मा वदिष्यामि हृदं वदिष्यामि सत्यं वदिष्यामि तन्मामवतु तद्भक्तारमवतु आवतु माम् आवतु भक्तारम्। ओम शांति शांति शांति। हरि ओम तत्सत्।
Yes. नमस्कार। आज स्वतंत्रता दिवस के इस पावन अवसर पर मैं आप सभी को हार्दिक बधाई देता हूं और ये कालखंड आजादी के अमृत महोत्सव का भी है। हम सभी लोग उन्नति करें, प्रगति करें एक राष्ट्र के रूप में, ऐसी मेरी कामना है। और जितने पार्टिसिपेंट्स हैं यहाँ पे, स्टूडेंट्स, वो आने वाले समय में इस देश का भविष्य होंगे। इस देश में के श्रेष्ठ वैज्ञानिक बने, श्रेष्ठ शिक्षक बने और श्रेष्ठ सिटीजन्स बने, ऐसी मेरी कामना है। आज का हमारा विषय है जियोस्पेशियल टेक्निक्स in geosciences. So how can we apply geospatial techniques in geosciences? ये हमारा आज का विषय है और इसी विषय में हम विस्तार से बातचीत करेंगे। Can you see the presentation in the full screen? प्रेजेंटेशन आप फुल स्क्रीन में देख सकते हैं। हेलो हेलो, अच्छा, बनिक साहब, और वॉइस भी आ रही है? माय वॉइस इज ऑडिबल? So today, on this auspicious occasion, we are discussing applications of geospatial techniques in geosciences, and our country has made great strides in almost all the cutting-edge technologies during past 75 years or so. So geospatial techniques are few of them. हम लोग ये जानने की कोशिश करेंगे कि what the geospatial techniques are all about. Geospatial techniques are comprise remote sensing, geographical information system, and global positioning system, and other techniques of like cartography and geovisualization, etc. So all these techniques put together are termed as geospatial techniques. Now we shall be discussing each of these techniques separately and then their applications in geosciences. So geoscience is a study of Earth. It is the systematic study of Earth, its origin, its evolution, and a study of different processes that are working on Earth, whether they are endogenic processes within the Earth or exogenic processes, which are because of the action of wind, air, or wind or water. So now each of the geospatial technique we shall be discussing one by one. Remote sensing is the first technique. Remote means दूर से, and sensing means to sense something, किसी phenomena को, किसी object को, किसी feature को अर्थ surface में महसूस करना, उसके बारे में information collect करना without coming into its physical contact. That is something called remote sensing. So here, without coming into the physical contact of a hill or maybe of a valley or of a river, we can picturize it, we can take an image of it, and we can analyze that image. So there are three major platforms of remote sensing. Number one platform one is space-based platform. Number 2 is aerial platform, and number 3 is ground-based platform. Am I audible? आप सुन सकते हैं मुझे? So it all about started with aerial photography, and when aerial photography was invented, some innovators tried to put cameras on board balloons to take pictures or photographs of their terrace or their building. So this was the most primitive type of remote sensing or aerial photography. But during First World War, the aircrafts were equipped with a camera, and there was a navigator with a pilot who used to take photographs of enemy territory to see the movement of their armored regiments, their tanks, their artillery, or their infantry divisions. And during Second World War, the colored photography had also been introduced, and it was automated by the time, and pilot was able to himself take the photographs of the territory of adversary from his aircraft. So after the end of Second World War, the humanity has made big strides in space science, and when satellites were launched into space, ever since 1957, the thought about taking images of Earth evolved, and finally it culminated into satellite remote sensing. And the first series of remote sensing satellites was that of Landsat, launched by USA. It was followed by Spot by France, and then India also became a powerhouse in this arena, in this technology arena. And we started our journey with IRS-1A, Indian Remote Sensing Satellite 1A. And nowadays we have one of the highest resolution remote sensing satellites into orbit, which are indigenously made and launched with our indigenous launch vehicle, PSLV, Polar Satellite Launch Vehicle. So aerial photography is something wherein we take the photographs of different parts of landscape or earth surface by mounting camera on an aircraft or maybe helicopter. And drone is the latest version of aerial photography, or UAV, that is unmanned aerial vehicle, wherein we are mounting a camera on drone or unmanned aerial vehicle, and we are taking very high resolution images of different parts of our Earth. So this is the latest of remote sensing techniques. And the full form of drone is dynamic remotely operated navigation equipment. It is also known as UAV, unmanned aerial vehicle, and nowadays it is also called as unmanned aerial system. It could be multi-rotor like a helicopter, or it could be fixed wing like an aircraft. But the future lies into drone or UAV remote sensing only. Then, so on aerial platform, we have aircrafts, helicopters, and drones on which we mount cameras to take photographs or images of Earth. Space-based platforms, they comprise satellites and spacecrafts as well, because we can also take image of Earth from a spacecraft or International Space Station. But remote sensing satellites are most frequently used platforms for satellite remote sensing. And the third platform is ground-based, wherein we are mounting the sensor or camera on a ground-based platform. It is like LiDAR is one such platform. LiDAR is light detection and ranging, wherein we use a ground-based platform, either a tripod or a SUV, wherein this LiDAR sensor is mounted to take images of any particular small segment, a small area, but the images are very high resolution. Very high resolution means very small segment can be seen through these images. Now, space-based platforms are basically of two types. We have three types of satellites mainly. First category is geostationary, other category is polar, sun-synchronous or remote sense satellite, and yet another category is that of military satellites or spy satellites. So I shall be discussing the first two here. So geostationary satellites, they are also called as communication satellites, and they complete one revolution about Earth in 24 hours, and Earth rotates about its axis in 24 hours. So the revolution of this satellite is synchronized with the rotation of Earth. So it completes one revolution around Earth in 24 hours, and Earth is completing one revolution about its axis in 24 hours. So it looks as if the satellite is stationary, but it is not, it is moving. And this satellite generally weighs from more than 2.5 tons, and it is placed at an orbit of around 36,000 kilometers above the surface of Earth. So these satellites are called geostationary because it appears as if they are stationary, and they are placed above the equator. These satellites are used for weather monitoring, for weather forecasting. Their transponders are also used for TV transmission, telecommunication. If we are seeing a live telecast of a match somewhere in some other continent, so for that purpose, transponders are used. For ISD calls too, the transponders of these geostationary satellites, they are used. So our series of Indian geostationary satellites is INSAT. INSAT 1 series was there, then INSAT 2, then now it is INSAT 3 series. So similarly, the type of satellite, they are remote sensing satellites, and they are lighter in weight as compared to geostationary satellites. So remote sensing satellites, they weigh somewhere around 1,000 kgs, and they are placed at an orbit of maybe little more than 500 kilometers to up to 1,000 kilometers, and they move from north to south. So their revolution is synchronized with the poles of Earth, rather. So they are rather polar sun-synchronous. So, and they pass over any particular area where there is appropriate illumination from sunlight of that area. And they complete one revolution around Earth within maybe little more than 1 hour, maybe in 100 minutes or 90 to 100 or 110 minutes. So they have revisit capability, and they can revisit above same area after a few days. So we can take images of any city or any village or any area within a span, very short span of time, using these remote sensing satellites. And as I told that in IRS-1A, Indian Remote Sensing Satellite 1A, which was launched from Russian launch vehicle more than 3 decades back, that had a resolution of around 36 meters with its LIS2 camera. So what I mean to say is, with that sensor, we were able to say a segment of around 36 meters by 36 meters on the surface of Earth. But nowadays, with Cartosat 3 satellite into orbit, we can see sub-meter level segments, or even those segments of Earth which are as small as maybe 25 to 30 centimeters by 30 centimeters. So remote sensing satellites are used for natural resources management, and we shall be discussing different applications of these satellites. They are used for forest mapping. They are used for surface water bodies mapping, for mapping river channels. These satellites, remote sensing satellites, are also used for agriculture applications, for mapping our crops, the estimation of area under crop cover. They are also used for mapping our soils. Remote sensing satellites are also used for mapping urban areas, rural areas, our coastal areas, hills, plains, plateaus. And with very high resolution sensors on board these satellites, if required, they can also be used for military purposes. So this space-based or satellite remote sensing, how does it work? So you see, it works in two ways. This is passive remote sensing, wherein the surface of Earth is illuminated from the sunlight, and then it is reflected back to the satellite, to the sensor of the satellite, and here the image is recorded. So this is called passive remote sensing because we need a source of light for illuminating the surface of Earth. So in optical, these are also called optical remote sensing. So in optical wavelengths, blue, green, red, and infrared, we use this passive remote sensing. But in case of radar remote sensing or active remote sensing, the sunlight is not required, and because radar or active remote sensing or microwave wave remote sensing, as it is variously called, it has its own source of illumination. So we don't need sunlight, and using radar remote sensing, we can take images of a terrain during evening time, even during early morning time when sunlight is not there or very little sunlight is there, even during thunderstorms or during cloud cover, during bad weather conditions. The images of flooded areas which are covered with clouds, they can be taken with radar or remote sensing. So once the sensor records this image, it is downloaded, and these are the kind of images that we see. These images are processed on computers, and then finally we get these maps. They could be geographical maps, they could be land use maps, they could be geomorphological maps, they could be maps showing different infrastructure. These are some of the satellites of IRS series, and now Cartosat series has also been added into it. And these are the type of images that we get from them. Like in this case, 23 meters by 23 meters segment of the Earth can be seen. Here 5 meters or little more than 5 meters by 5 meters segment of the Earth can be seen. So then there is a technique called digital image processing, because we use two techniques to process these images. Number one is visual technique, wherein we visually interpret these images from our eyes. A forester will try to see the forested area within these from these images. A geologist will try to see features of his interest from these images. Urban planner will try to see the features of these his interest from these images using just through visual interpretation. Then the technology of digital image processing or digital image processing techniques, they have also evolved, because human eyes cannot separate more than 16 shades of colors. And on computers, we can even see 256 shades of colors. So then these images are now processed on computers using different image processing techniques. And you see their variance covariance matrix or correlation matrix is used to process these images. And by processing these images using digital image processing techniques on computers, we can get a lot of information of our interest, whether it is pertaining to our roads, our railway lines, our infrastructure, our land use pattern of our cities or villages, or surface water bodies, or soils or forest cover. Now, one more technique in addition to remote sensing that falls in the realm of geospatial techniques is geographical information system, that is called GIS. And you see, GIS is something that comprises hardware, software, and humanware. Nowadays, we can use GIS on our smartphone itself. We have so many OpenGIS softwares available which are freely downloadable. So this is geographical information system. It's basically a computer-based data management system wherein we can analyze any geographical data and we can retrieve it, we can analyze it, we can create simulations or models using that data, and we can have even decision support systems using this data. And then remote sensing data can also be an input to the GIS, because remote sensing technique is independent to GIS. If we have a satellite image, we can also put it as an input to the GIS system. And in Hindi, we call it Bhaugalik Suchana Tantra or Bhaugalik Suchana Pranali. So this is how GIS works. Number of layers are there, and one of the layer could be of remote from satellite remote sensing or aerial remote sensing. I will show you this slide again. This is how you see the lowermost layer is that of satellite image, and some other layers which we can extract or generate from a satellite image or other sources. They can also be put together. Like base layer comprises roads, railway lines, some settlements, then elevation layers. All the available layers, geology, land use, groundwater, soil maps, hazard zones from the point of view of disasters, whether they are landslide hazard zones in a hilly area or flood hazard zones in any maybe hilly area or plain area. They can, those maps showing these zones, they can also be put as input. And then all these layers, they can be integrated using geographical information systems so as to have action plans for our developmental planning. This way we can create action plans for forest resource management, for planning of new routes or highways, for our soil resource management, for optimal utilization of our groundwater and surface water resources, for sustainable utilization of our earth resources, forest resources, water resources, agriculture resources. We can use these GIS techniques or GIS-based models, which are also called as decision support models. So, because they help us in decision making for planning any new infrastructure project or facility. So one more technique is that of GPS. Because of paucity of time, I will not be able to discuss that technique in detail. GPS or GNSS technique, that is also called. GPS is Global Positioning System, which is a constellation of satellites launched by USA to get the precise information about the coordinates or latitude or longitudes of on any point of Earth. Then Russians have their own system that is called as GLONASS. And then European agency, they have their system that is called Galileo. So all these systems, they are together called as GNSS, Global Navigation Satellite Systems. And India also has a regional satellite navigation system, IRNSS, Indian Regional Satellite Navigation System, which works within Indian territory and 1,500 kilometers beyond it, in Arabic Sea, Bay of Bengal, Indian Ocean, and towards western and northern margins of the country. So this remote sensing, GIS and GPS together, they constitute what is called geospatial techniques. What are called geospatial techniques? How do we use them in geosciences? As I told in the beginning, the geoscience is the study of Earth, its evolution, origin, evolution, and its resources, biotic or abiotic resources. So these techniques, geospatial techniques, remote sensing, GIS and GNSS, they are best utilized in river migration studies, in river mapping, lineaments and faults mapping, in mineral mapping, mineral prospecting, geoenvironmental aspects, and in landslide hazard zonation and flood hazard studies as well. Am I audible? Okay, thank you. So how do we map rivers? We can map rivers and their ancient channels, their old pathways where they were flowing in the past. Those can also be mapped using these techniques. And ancient channels of rivers are called as paleo channels. Paleo means ancient. So the earlier pathways of rivers through which they were flowing in the past, maybe 100 years back or 1,000 years back, they can also be mapped. And this is one pathway which is mapped here using this satellite image, because here we see the tone is darker and the moisture is high. That's why the tone is darker, and then it is curvilinear in shape. It is juxtaposing the present-day river channel. So all these point towards this being an old channel of the river. And this way, once we digitize them, we can have these channels like this. And this way we can map a number of old channels of the river. Then they need to be verified in the field, and in the field they appear like this. You see, this is a very broad course of the river, but the water is occupying a very small part of it. It's called misfit in geology and geography. Means most of this channel, earlier river has died out or dried out or died out. So sometimes they are completely dried away. And I think remote sensing, satellite remote sensing is one of the best techniques to map these old channels of rivers. And you see what for we are mapping them. Because these ancient channels or paleo channels of rivers, paleo drainages, if we just reconstruct all of them on a map, they will be called paleo drainage, the ancient drainage. So they are basically excellent sites for groundwater targeting. So if we dug a tube well here, we will be getting water at a very shallow depth. Although these remote sensing based studies are supplemented with certain geophysical surveys for groundwater targeting or for pinpointing the location for tube wells or hand pumps. So why we are mapping these? We are mapping these old channels of the rivers to get some groundwater prospecting zones, number one. Number two, These old channels of the rivers, they are generally waterlogged during rainy season because water table is at a shallow depth in these areas as compared to the surroundings. And during rainy season, the water table comes onto the surface and they witness waterlogging conditions. So we can just avoid habitations in these areas. So that way they are useful. And thirdly, if we are constructing the old drainage of the river, they are of academic importance and they are also useful for civil engineering projects because we cannot construct any civil engineering project, any apartment building here because it will be waterlogged during rainy season. Secondly, you see many river confluences, they migrate because sometimes rivers capture each other. They capture a part of the flow path of other river, its tributary. And you see some old topographical sheets of 1922-23, wherein the confluence, this confluence was here, river confluence, and then the satellite images of 90 years afterward, they have been compared. So the topo sheets of 22-23 have been compared with the satellite image of 2012. And what has been noticed is the confluence of these two rivers, it has migrated some 13 kilometers up the stream. So this migration, this drastic migration or shift of confluence of the rivers is very important from the point of view of disaster management. Because once the confluence shifts, it causes bank line shift, severe bank erosion, and many villages are wiped out and cropland is lost due to erosion. Forested areas are also lost. And so by studying the trend of migration of rivers through conjunctive use of satellite remote sensing and GIS, we can have some idea about the future pattern, future flow pattern of these rivers and the dynamics of their confluence, which helps us in preparing the flood management plans on measures for bank protection and measures for minimizing the bank line shift of the rivers. Here, there is another aspect. Remote sensing and GIS, it is an excellent technique, as I am already explaining, for monitoring the migration of rivers. You see here, the river channel, as it was in 1973, it was mapped, it was digitized. And then in 1999, again, it was digitized from two different images, satellite images. When using this GIS, these two maps, because in GIS, as I told you earlier, we are superposing one layer over the other. So in this case, what we have done is, we have superposed the map of river configuration of 73 and 99. And what we have come to know that this river channel, as it was in 73 in this segment, it has migrated around 3 kilometers, close to 3 kilometers southwestward. The migration is shown with red arrow during 3 decades or so. So had we constructed a bridge here, it would have wiped out, a part of it would have been wiped out. So the sectors of the rivers which are witnessing migration, channel migration, particularly in plain areas, rivers witness channel migration, not in hilly areas. So in plain areas, the segments of the rivers which are witnessing migration, which are shifting, they are worst sites for any barrage or bridge, or even for any road for that purpose in their close proximity, because that will be eroded. And you see, this is one segment where river has undergone minimum migration, so this is a good site for laying a bridge. Now, in case of risk reduction for our infrastructure, you see this is a gas pipeline, Hajira Bijapur Jagdishpur pipeline, which supplies gas from Gujarat to Mathura refinery in Uttar Pradesh. And now this gas pipeline was under threat of wear and tear from river migration here in this area. And it has been studied using many satellite images of multi-dates of different years. And then these channels of different years, they were drawn from satellite images. It was noticed that the river was shifting towards gas pipeline. So generally, the gas pipeline is laid at a shallower depth when it is not going beneath the river channel. If it is going beneath the river channel, if it is crossing the channel, there it is laid at a greater depth as compared to the other places. So some structural mitigation measures, they were taken, or some channel dredging was done, and then an alternate channel was also dredged here, so that to divert the flow of the water and to safeguard this gas pipeline. So here the remote sensing technology has provided some valuable or critical inputs for this kind of disaster risk reduction for our infrastructure facility, which is gas pipeline in this case. Now we also carry out landform mapping from remote sensing technique, which is called geomorphology. Geomorphology means the study of landforms. So whether they are active floodplains, old floodplains of the rivers, they are also mapped. And within these, as I told earlier, all the old channels, they can also be mapped. So yellow is active floodplain, orange is old floodplain. So by mapping these floodplains of the rivers, we can come to know that which is the area which will be flooded, which can be flooded every year, because active floodplain can be flooded every year. So we can plan our cities, towns accordingly, so that we don't start constructing in the active floodplains. We should also desist from urban expansions in old floodplain areas, because they can also be flooded during high flows in the river. I think many of the students, they might have heard of lineaments and faults. They are called geological structures. As we know that our Earth's surface is traversed by many faults at various places, and the faults could be of few meters length, or they could be of hundreds of kilometers in length. So those faults which are of few hundred meters of length, they can be mapped using satellite remote sensing. And with drone or UAV technology, we can even map faults of maybe few meters length. So if there is a displacement along any linear feature on the surface of Earth or below it, then it is called a fault. But if the rocks are not displaced, and it is simply a linear feature on the surface of Earth, it is a natural linear feature which is expressing some sort of drastic change in the topography on both sides of it, or maybe in the elevation, then it is a lineament only. So using this remote sensing technique on satellite images, we can map a number of such faults and lineaments, which are shown here in this map. And this is of great relevance to geologists and geographers, and also to the civil engineers. Because generally faults, and if they are active faults, if there is movement also going on at present along any fault, then we generally avoid any civil engineering structure in that particular area. And if that structure is to be laid, it has to have some measures for its stability, some additional measures for its stability. Now, this is how we can see these faults or lineaments in the field, their expression. In the form in alluvial regions, their expression is generally in the form of these alluvial regions. And you see many of these are the field evidences. And because of anthropogenic activities, we are gradually losing many of these field evidences, because some of the mounds alongside of the river, they could be relevance when we are trying to depict a fault on the field, or when we are trying to collect evidences for its presence in the field. But many of these mounds or alluvial ridges, they are now being obliterated because of human activities. So they are digging soil from these, and we may not see many of them in the years to come, particularly in the plain areas. Now, for planning any civil engineering project like a power plant, whether it is thermal power plant or nuclear power plant, we can use these techniques for site suitability studies. And the satellite images help us to demarcate, as I already told, faults, lineaments, and different landforms. And by studying these features in detail, we can reach to a conclusion regarding the stability of that site for any thermal power plant or nuclear power plant. You see, for planning many important infrastructure projects, these techniques are used. And I have had the privilege of carrying out the mapping of this Bogeyville Bridge way back in 1997 when I visited Assam. And this bridge was planned at that time to link Lower Assam to Upper Assam. And you see the Brahmaputra River near Dibrugarh. We mapped this river, and here the objective was to see that which of the islands of the river or which of the sandbars of the river are stable for placing the pillars or piers of the bridge, and is river witnessing bank erosion. So all those things were studied. And you see, this is the site of this rail cum road bridge, which has been inaugurated a couple of years back by Honorable Prime Minister of India. And it has connected Lower Assam to Upper Assam, and also improved our connectivity to Arunachal Pradesh. So for this kind of important infrastructure and strategic projects, remote sensing techniques are of great relevance, because here we use satellite images of different years of this area of Assam to map Brahmaputra River, to map its different sandbars, and to map their dynamics, the pattern, the changes in them because of the floods in Brahmaputra River. Now, in addition to the mapping of river channels, we can also use geospatial techniques for mineral targeting, for prospecting economic minerals, for searching the minerals which have economic value. And we use these technologies for targeting iron deposits, gold deposits, copper deposits, number of mineral deposits which are of economic value. And here too, although the remote sensing technology is not as effective as it is in case of river studies, as we have seen earlier, but here too, we can use remote sensing to a great extent, particularly in the hinterlands, in very remote areas, because we don't get economic minerals somewhere in the proximity of a city, or within a city, or within an urban area. If we are going to find minerals, economic minerals, they might be in hinterland, somewhere in the plateau area, somewhere in the hills, or somewhere in the hinterlands, which are dense forests. So here, remote sensing is used for preliminary surveys, reconnaissance surveys, so that the area of detailed survey is reduced for our geologists. And then we can also see the anomalous pattern of landforms topography for demarcating some anomalies, and if there are suitable host rocks, because each mineral is found in a particular rock. So if there are those suitable host rocks, there is probability of that mineral. But once the preliminary survey is done using satellite remote sensing techniques, then they are followed by detailed field surveys, and then rock samples are collected from the field, and some other techniques other than the remote sensing and geospatial techniques they are used, like geochemical techniques, for knowing the what is basically the ratio of that particular mineral within that rock, or whether or not it is economically exploitable. Nowadays, UAV, unmanned aerial vehicle or drone-based studies are also being carried out for mineral targeting. And you see, we carried out this study with Northeastern Space Application Center, which is close to you. It is in Uniyal near Shillong, and that Northeastern Space Application Center and we, a Remote Sensing Application Center, Uttar Pradesh, Lucknow, together carried out this study in a part of Bundelkhand area, which covers some parts of Uttar Pradesh. So using drone or UAV, and here, as I told you, that even faults of few tens of meters, they were also mapped. So this is, I think, this is the future of remote sensing, UAV or drone-based remote sensing. And this is UAV or drone, and this is how the image that is taken. And we can take centimeter resolution images from drone, because if with the satellite we can with Cartosat 3 satellite of India, we can have an image of 25 centimeters by 25 centimeter ground resolution, because means it can see a ground segment of 25 centimeters by 25 centimeters. In case of drone, we can see even higher resolution image, or we can have even higher resolution image than the satellite, than the highest resolution satellite. Because using drones, we can have satellite images of, using drones, we can have images or drone images or UAV images, which are of the resolution of more than even 20 centimeter or more than 10 centimeter. So what I mean to say, that very small segments of 10 centimeter by 10 centimeter on the surface of Earth, they can also be used using drone or UAVs. Now, apart from this river migration study, infrastructure planning study, mineral targeting study, we can also use these remote sensing and GIS techniques for geoenvironmental studies. Geoenvironment means where the landscape is obliterated or changed, or land use is changed due to the activity of mining or waste disposal or slope cutting for road construction. How can we do it? You see, on satellite images, we see these white patches. These big white patches, they are basically the areas of stone quarries. So if we take another image of this area, maybe of next year or 2 years earlier, we can compare those images, and we can see that whether this area of stone quarry has increased or decreased. And sometimes the quarry waste is dumped into the fields, and our agricultural land is transformed into wastelands. So how much hectare of agricultural land has been transformed into wasteland? That can also be mapped, that can also be done using these remote sensing and GIS techniques. And you see that we are changing landscape to such an extent that it appears as if it is a hill. It is not a hill. It is a dump of waste of granite quarry. But it looks as it is, if it is a hill, it is 60 to 70 meter high. But it is a man-made dump. And here you see that this is some more than 10 meters deep quarry area of sandstone quarry. So we have made this positive landform into a negative landform because of the mining activity. So how much area has been changed, that can be mapped on satellite images. Here you can see that those areas have been digitized with yellow line. I think we are heading towards the last leg of the lecture. Now, in disaster management too, we can use this. Sometimes else we will discuss in detail, but here we will be discussing it in very short. You see, hazard into vulnerability is equal to risk. Hazard is, it could be anything like flood, landslide, earthquake. It is a hazard. So vulnerability is degree of damageability. If we have many habitations, if we have many habitations within that hazardous area, then the vulnerability or degree of damageability of that hazardous area is very high, and the risk will be high. So hazard multiplied by vulnerability is risk. And if we can bring down vulnerability to zero, the risk could be zero. So using different scientific techniques, including remote sensing, GIS and GPS, which are together termed as geospatial techniques, what we can do is we can reduce the vulnerability. We cannot prevent a flood, we cannot prevent a landslide, we cannot prevent an earthquake, but we can certainly bring down vulnerability. And if we can bring it down to zero, anything multiplied by zero will be zero. So if hazard is 100, R is scale of 100 and vulnerability is zero, the risk will be zero, because 100 multiplied by zero is zero. So how do we do it? We do it through conjunctive use of remote sensing, GIS and GPS techniques. Here in this very slide, I am showing you what digital elevation model, which has been created using satellite images. And this model has been created using GIS techniques of a hilly region of Himalaya. And on this digital elevation model, we have superposed satellite image, and then all the active landslides which are seen in yellow color as yellow polygons. So, and this is how these landslides appear in the field. We can also create digital elevation models, 3D models, using height points or contours. Contours are lines joining points of equal heights, and then we can use these models for prognostic modeling of future landslides. And this was done in one case where this model was created for a patch of small city of Himalaya. And you see one slide was there, only one landslide was there sometimes back, and 2-3 more landslide emerged, but not even single human casualty was there. Although it was slow flowage, not rapid flowage, but the people were well aware, the administration was well aware of the fact, and many technologies were put together to understand the behavior of this landslide. And once it started as a slow flowage, the entire area was evacuated within 2-3 hours, and it continued, the landslide continued for 24 hours. So not even one human life and a cattle head was lost. This might not be true in case of rock falls, but in case of many landslides, we can minimize the damage, particularly the human casualties, if we have proper landslide hazard maps using remote sensing, GIS and GPS techniques. And sometime else I will explain that how we prepare a number of thematic layers for landslide and flood hazard zonation, like layer of land use, geomorphological map, drainage map, road, railway line, and then slope aspect. And then all these layers, they are combined, they are integrated using GIS to prepare landslide hazard map. And similarly, with few more layers, integration of few more layers, flood hazard map, zonation maps are created. And these maps help us for our mitigation planning, whether it is for landslide hazard or flood hazard. We will discuss those in details on some other occasion. This is one example of Kedarnath, which is an important Himalayan shrine. And you see that similar floods were witnessed by this shrine in 1882. But at that time, the vulnerability was very less. Some 5, 6, 7 huts were around the temple, and few people were there around. There might be maybe 10, 20, or 30. But in 2013, there were more than 19 lodges or hotels or dharamsalas, and thousands of people were there. So the vulnerability was very high. And as a result of that vulnerability, we lost many precious human lives, the exact number of which was in thousands and is not known even till date. So what can we do is we can reduce the vulnerability. We should desist from expanding our cities, towns, particularly in the hazard zones, because the flood will occur sometimes sooner or later. Landslide will occur in a hazard zone. So it is better to avoid it for new development so as to reduce the risk. I will end this session with this poem of mine, which was published in Vigyan Pragati and Asker magazine. It is on geospatial techniques. And if I have to explain within a minute or so what geospatial techniques are all about, I will explain them as in a poem. मानव निर्मित उपग्रह हो या हो अंतरिक्ष यान, वायुयान हो या ड्रोन हो या गतिशील या भौम lidar. गतिशील and भौम lidar means mobile and terrestrial lidars. मानव निर्मित उपग्रह हो या हो अंतरिक्ष यान, वायुयान हो या ड्रोन हो या गतिशील या भौम lidar, ये सभी देते धरती का ज्ञान, विज्ञान और विस्तार। आत्मसात कर सके यदि हम ये देते ज्ञान का भंडार। नगर हो या गांव हो या खनन से धरती पर बने घाव हो, नगर हो या गांव हो या खनन से धरती पर बने घाव हो, खेत हो या खलिहान हो या घास के मैदान हो, तालाब नदी या पोखर या हो वन या वन्य धरोहर, भू धसाव हो, जल भराव हो या धरती का कटाव हो, खेतीहर हो या उसर हो, दलदल हो या बंजर हो, हर प्रकार की भूमि के चित्र हमें मिल जाते हैं। उपग्रहीय चित्र, हवाई चित्र पॉइंट क्लाउड कहलाते हैं। The images, here what poet wants to poeticize is that the images if taken from satellite, they are called upagriya chitra. If taken from aircraft, they are called Hawaii chitra. If taken from radar, they are called point clouds. कंप्यूटर तकनीकों से विश्लेषित किए जाते हैं चित्र, कंप्यूटर तकनीकों से विश्लेषित किए जाते हैं चित्र, अल्प समय में इन चित्रों से बन जाते हैं मानचित्र। भौगोलिक सूचना तंत्र से एकीकृत होते मानचित्र, निर्णय सहायक तंत्र से सज्जित होते हैं मानचित्र। भौगोलिक सूचना तंत्र मीन्स GIS. GIS is used to integrate them, and निर्णय सहायक तंत्र से सज्जित होते हैं मानचित्र। The meaning is that these maps have decision support system embedded into them. इन तकनीकों से त्रिविमीय मॉडल भी बन जाते हैं, 3D मॉडल्स we are talking about. इन तकनीकों से त्रिविमीय मॉडल भी बन जाते हैं जो पृथ्वी की ऊंची और गहरी सतह दर्शाते हैं। वास्तविक धरातल छोटे पैमाने पर दिखता है, पर ज्यामितीय मापन में यह सही टिकता है। मिल जाते हैं अक्षांश देशांतर वैश्विक स्थिति उपग्रह प्रणाली से। This is global navigation satellite system. We are talking about that. मिल जाते हैं अक्षांश देशांतर वैश्विक स्थिति उपग्रह प्रणाली से। सटीक भौगोलिक स्थिति दिखती इस GNSS बलशाली से। कहीं जियोस्पेशियल या भूस्थानिक इन तकनीकों को या अद्भुत कहे विज्ञान की इन तरकीबों को। धन्यवाद, थैंक यू। जय भारत, भारत माता की जय, वंदे मातरम। धन्यवाद। हाँ जी, डेफिनेटली, निश्चित रूप से मैं कोशिश करूंगा।
Sir, good evening.
Good evening.
Dr. Aniruddha, I was just listening to your the webinar, so I was little bit astonished fully. Means that fabulous presentation you have given. What I want to ask you is like how we can inculcate the spirit of the curiousness for spatial studies, because nowadays I am in teaching background. What I want to say is like students, they are unaware, they want to explore more. So how we can inculcate or provide them the knowledge to go into the space field. Thank you, sir.
Thank you. Can you please tell your name?
Sir, my name is Rajiv Jain. I am from Moga, Sacred Heart School, Moga, Punjab.
Thank you, Jain sir. What we can do is that our students can Google Bhuvan, BHUVN, Bhuvan. Bhuvan is a site of ISRO. So it is on the pattern of like Google Images. So if they just search Bhuvan, they will find a number of satellite images of different parts of our country, whether it is Indus Plain, where lies Punjab and Haryana, or it is Ganga Plain, where lies Uttar Pradesh, Bihar, or parts of Bengal, or it is Brahmaputra Plain, where lies parts of Assam. So what I mean to say is that by seeing this Bhuvan site, so many maps are there, so many satellite images are there, different types of satellite images are there, even images of satellite images of our entire country, India, is there. And once they will search this Bhuvan site, they will find so many good things about this spatial techniques. Then our center, rsscup.org.in, rsscup.org.in, Remote Sensing Applications Center, Uttar Pradesh. So if you search our site, you will see so many things. Like during this rainy season, the flood maps are there. By clicking that link, you can see the flood maps. So similarly, on Bhuvan site of NRSC, National Remote Sensing Center, Hyderabad, which comes in under Department of Space, Government of India, you can see the flood maps of your state. You can see different resource maps, land use maps, infrastructure maps of your state, your district, or entire country. So if students will try to search that using that Bhuvan site, they will have interest into it. Or then Google Images, they can also see Google Images. And Google Images are not available for Earth, only for even Mars and Moon too, they are available. So Google Earth Images, they can also see so many things. So by seeing these images, definitely this strong feeling of studying these techniques will inculcate among them.
Thank you, sir. Thank you for giving this information.
Because a picture, I think a picture speaks of 1,000 words, and a map speaks of 1,000 pictures. So if they see pictures, they will understand easily rather than we lecturing them. हाँ जी डेफिनेटली आपने शायद पॉइंट आउट भी किया था मुझे, बट मैं उस एस्पेक्ट को कवर नहीं कर पाया, बहुत कम टाइम था. रिमोट सेंसिंग के जो कोर्सेस है मेनली वो पीजी पोस्ट ग्रेजुएशन लेवल पे ही होते हैं, और देयर आर मेरी यूनिवर्सिटीज जो एमटेक कराती हैं रिमोट सेंसिंग में, और रिमोट सेंसिंग जीआईएस में भी एमएससी होती है, और जियो इन्फॉर्मेटिक्स के नाम से भी होती है, एमएससी इन जियो इन्फॉर्मेटिक्स भी होती है. सो उसमें भी एमएससी या एमटेक किया जा सकता है. एंड प्राइवेट सेक्टर में इससे बहुत अच्छा स्कोप है. बहुत सारी कंपनियां हैं जो इंफॉर्मेशन टेक्नोलॉजी में आईटी सेक्टर में काम कर रही हैं, वो रिमोट सेंसिंग के प्रोफेशनल्स को भी लेती हैं. और अगर आप देखेंगे इंडियन इंस्टीट्यूट ऑफ रिमोट सेंसिंग देहरादून उत्तराखंड में है, जो कि एक प्रीमियर सेंटर है रिमोट सेंसिंग का। वो लोग एमएससी भी कराते हैं रिमोट सेंसिंग में, एमटेक डिग्री भी कराते हैं, नीदरलैंड से भी कोलैबोरेशन है उनका, वहां से भी वो डिग्री कराते हैं। हमारा रिमोट सेंसिंग एप्लीकेशन सेंटर उत्तर प्रदेश है, हम लोग भी एमटेक एक रिमोट सेंसिंग जीआईएस कराते हैं, जो कि ऑल इंडिया काउंसिल फॉर टेक्निकल एजुकेशन से अप्रूव्ड है। इस तरह से बहुत सारी यूनिवर्सिटीज है हर स्टेट में जो कि रिमोट सेंसिंग में मास्टर्स डिग्री कराते हैं। और मेनली जो लोग रिमोट सेंसिंग में काम करना चाहते हैं, बेसिकली दे शुड हैव ए बैचलर डिग्री आइदर इन ज्योग्राफी, जियोलॉजी, सिविल इंजीनियरिंग, कंप्यूटर साइंस, बॉटनी, फॉरेस्ट्री, एग्रीकल्चर, सॉयल साइंस। मैं रिपीट करूंगा, all those who are interested in taking up their career in the field of remote sensing, they should have a bachelor's degree in geology, geography, civil engineering, computer science, agriculture, soil, forestry, botany, even archaeology. So they can opt for it. And even अगर physics में भी है ग्रेजुएट डिग्री, दे कैन ऑल्सो ऑप्ट फॉर इट। जियोफिजिक्स में भी अगर है ग्रेजुएट डिग्री, सो दे कैन गो फॉर इट। और बहुत सारे स्टूडेंट्स मास्टर्स डिग्री के बाद भी रिमोट सेंसिंग के लिए ऑप्ट कर रहे हैं, जिसके 1 ईयर के डिप्लोमास भी होते हैं और 2 ईयर के एमटेक प्रोग्राम्स भी होते हैं। सो आई थिंक इन द डेज टू कम these geospatial techniques are going to grow like anything, and all those who are interested in working in this field, they can work in the radar remote sensing, UAV remote sensing, lidar remote sensing, I think, and hyperspectral remote sensing. जो लोग हायर स्टडीज चाहते हैं, स्पेशलाइजेशन चाहते हैं, अच्छा अच्छा, आपका वॉइस नहीं आ रहा है क्लियर, लेकिन हाँ जी हाँ, लिटिल इट इज लिटिल बेटर।
I would like to ask you
Banik साहब, अगर if you can repeat his question to me, if he is audible to you, तो Banik sir, you can please repeat his question to me.
I would like to there is whole iron.
So आप सुन पा रहे हैं बनिक साहब उनकी आवाज? तो आप मुझे रिपीट कर सकते हैं क्वेश्चन। हाँ जी, चैट बॉक्स में आप लिख सकते हैं। और आप बनिक साहब आपसे क्वेश्चन लेके फिर मुझे कन्वे करा सकते हैं, तो मैं जवाब जरूर भेजूंगा आपको बाद में भी। व्हाट्सएप पे जवाब भेज दूंगा। थैंक यू सर, धन्यवाद, नमस्कार, जय हिंद, जय भारत।
तो ये था, हमारे साथ जुड़े हुए थे डॉक्टर अनिरुद्ध उनियाल जी, जिन्होंने इतनी देर तक हमें भारत की सैटेलाइट इमेजेस के बारे में और भारत को आत्मनिर्भर बनाने की ओर ये सैटेलाइट इमेजेस किस तरह से काम कर रहे हैं, इसके बारे में हमें बताया। आप सब इसके साथ बने हुए हैं। फेसबुक पर हमारी ये पेज लाइव है, उस पर जहाँ पे फेसबुक इंडिया इंटरनेशनल साराभाई स्टूडेंट साइंटिस्ट अवार्ड पेज पर, और फिर हमारे साथ यूट्यूब में भी, यूट्यूब की चैनल पर भी आप जितने भी लोग हमसे जुड़े हुए हैं, आप सभी को एक बार फिर से अमृत महोत्सव के अवसर पर नमन, वंदन, अभिनंदन करते हुए इस कार्यक्रम को यहीं पे समापन करते हैं। वंदे मातरम, जय विज्ञान, जय अनुसंधान।